Hi, my name is Otis Sloan Wood, and I'm an architect and researcher based at the Royal Danish Academy in Copenhagen. I was one of the architects based in Mtwara, Tanzania, coordinating the design and construction of the Star Homes project. In this video, I'm going to briefly discuss how the design choices we make not only impact human health, but also planetary health. This might be through designing a building that is reliant on air conditioning to keep it cool, requiring large amounts of electricity, which may in turn result in high energy production emissions, or through the use of materials that emit large amounts of CO2 or other greenhouse gases through their production and transportation. As Saloom mentioned, we are seeing many new houses are being built in materials with high embodied energy, such as concrete block. Concrete already has a huge environmental impact in its production, and according to a report from Chatham House, concrete is responsible for 4 to 8% of global CO2 emissions and uses a tenth of the world's industrial water supply. Given the scale of the housing demand projected in Sub-Saharan Africa in the next decades, the continued use of concrete block as a primary material in construction could lead to large-scale emissions. Therefore, we should be aiming to reduce its use and seek alternative materials. The Star Homes project has focused on two key strategies to reduce its impact. The first is to use materials more efficiently and use materials that can be reused. This reduces the embodied carbon and cost as less materials are used. In the Star Homes design, this can be done through optimizing the structure to use fewer members that can also be reused, using hollow walls to reduce the concrete, the use of lightweight materials such as shade net for the facade, and creating a double-storey building to reduce the footprint of the foundation and roof, two of the most expensive and energy-intensive elements of a typical house design. We carried out initial comparison studies using Building Information Modelling, BIM or BIM, to quantify the amount of materials and their embodied carbon with a typical concrete block house. These studies indicated a 70% reduction in concrete and 37% reduction in embodied carbon per metre squared compared with the typical concrete block house construction. There are still challenges using BIM and life cycle analysis tools in this context due to a lack of available data on material production emissions in the region. The second strategy was to create buildings that require little to no operational energy use. This can be through the use of passive strategies, such as natural ventilation to temper indoor climate, or through resource capture, like solar power or rainwater harvesting. The Star Homes design presents a series of health interventions that can be adapted to different house configurations and materials. Sub-Saharan Africa has a rich wealth of locally available natural materials such as timber or bamboo that, when sustainably managed, sequester carbon in their growth. Challenges still remain in tracing timber to ensure it's been sustainably harvested and how to detail and treat natural materials so they are not damaged by insects such as termites. However, this presents exciting opportunities to design housing from natural materials that aims to both reduce health impacts and its impact on our planet's health too.